Hello, everyone. My name is Tejas. I'm Principal Program Manager at Microsoft for SQL Server Product Group. I lead Microsoft strategy for SQL Server on Linux and Linux containers. Today, what we are going to talk about SQL Server on Linux and what's new for that in SQL Server 2019 and over a period of last 1 year. Now, before we go forward, it would be important to talk about, important to look back and understand what has happened with SQL Server on Linux and containers. Now, SQL Server was introduced on Linux platform with SQL Server 2017. It is supported on Red Hat Enterprise Linux, SUSE Enterprise Linux, and Ubuntu. You can also deploy it in container format in Kubernetes or OpenShift or even standalone VMs. It is available for you to install in a normal package-based installation in the Linux platform. Of course, it is available for deployment on Windows Server as well. Now, the most critical thing for everybody to understand is that we have complete database compatibility across Windows and Linux as a platform. What that means is that you can basically back up a database from SQL Server on Windows, restore it on SQL Server on Linux or even container, and execute the same query and get the same results. So how did we achieve that? Now, I won't go into the too much technical details around it. What I wanted to just indicate is that SQL Server team worked with Microsoft Research to create a component called SQL PAL, or the Platform Abstraction Layer, and that allows us to run the same Windows binary on both Windows and Linux as a platform. What that means is that we get complete compatibility for SQL Server on both Windows and Linux platform, and you get the same SQL Server functionality, including the SQL Server agent as well. Now, along with that, though, we also added support for some native Linux features, such as the pathing of Linux, you get the same installation experience for the Linux, which is based on packages. And we invested a little bit on the tooling aspect for the Linux as well. So you get the same, you get the Linux native tooling on the Linux platform. Now, what I'm going to talk about is, I'm just going to provide a brief overview of what SQL Server 2019 is all about. And SQL Server 2019 overall revolves around solving the modern data challenges. Now, we understand that most customers have fairly heterogeneous environment, and the new improvements with respect to data virtualization and big data clusters allow you to consolidate your data across across your entire data estate and build analytics on top of it. You get the built-in machine learning and language extensibility as well, and we are going to talk a little bit more about that later. And you get the high availability with accelerated database recovery as well. And we have also adopted the most modern platforms with SQL Server being available on Windows, Linux, and even ARM64 now with Azure SQL Edge. Now, let's talk a little bit more specifically about SQL Server 2019 on Linux itself. What is new over here? So we have focused upon ensuring we have parity in terms of the functionality and experience for SQL Server on Windows and Linux. We invested very heavily based on our customer feedback to include the replication and CDC functionality. We also have machine learning capability and language extensibility with Java. We have poly-based functionality on SQL Server 2019 on Linux as well. And on top of that, we also added support for most modern OSs like RHEL 8, Ubuntu 18.04, and we are also planning to support /15 in near future. We also added some support for the new hardware capabilities, such as persistent memory, which is becoming fairly ubiquitous in most environments. And SQL Server on Linux supports enlightened I/O as well as hybrid buffer pool features against on top of persistent memory. Now, let's talk, about some features more specifically. What is a SQL Server Polybase? So heterogeneous data access is not new to SQL Server. It's been there in SQL Server for over 20 years with remote servers and linked servers. In SQL Server 2016, the support for remote Hadoop data access was integrated with Polybase functionality. What we realized is that the method of accessing the remote Hadoop or big data sources versus the traditional relational data sources was divergent, and SQL Server 2019 basically rewrote the entire Polybase functionality to include both relational and big data sources, big data remote sources accessibility, and with the same kind of semantic layer. So basically, you should think of Polybase as a more of a semantic layer. What it allows you to do is create external tables against remote data sources, like a table in Oracle or table in another SQL server. And it allows you to define views on top of those data sources, and allows you to create and once you have defined external table, from the SQL Server query processor perspective, it just becomes another table with the same kind of metadata. So you can join remote data sources and local data sources seamlessly. So basically, what this allows you to do is essentially it detaches the two experiences, how to access the remote data sources versus what you want to do with the remote data sources. And this way, the administrators for SQL Server, they can focus upon defining the how part of the access to the remote data sources, while the analysts and the application creators can focus upon how to make use of the remote data sources once they have been defined and made available. So let's just take a look at the demonstration of Polybase, and I have pasted a link over here, which I used to configure Polybase on the SQL Server on Linux. So once again, I'm back into SQL Server 2019 installation on Ubuntu Linux, and I have installed appropriate components for Polybase architecture. The setup for that is well defined on our online documentation. Now, I have one database inside that AdventureWorks 2017, and let's say I want to explore additional data set from remote data sources and create external tables upon them so they can be used for additional processing from within AdventureWorks 2017 database. So let's see what that looks like. So I just click virtualize data, and now immediately it gives me different type of data sets that remote data sources that I can access. For example, in one of the type of remote data source that I can access is an Oracle data source. So let's just try to see if we can access one of those data sources. I already created one Oracle sample data source, so I'm just going to use that. And let's see if we can explore that. And now I'm accessing a remote Oracle server, and immediately I can see all the tables and views that I have access to, and I can create external tables upon. So, for example, let's see if I can pick a very known data source. Okay, so I created this one sample table on the Oracle server, and now I'm trying to create an external table on top of that. So let's see what that looks like. And on the right side, as you can see, I can do appropriate column mapping and even the appropriate schema mapping as well. And if I hit create, it will create the remote table for me. It's as simple as that. Instead of creating this, I'll just show the table that I already created. So for example, I already created a table external table on the remote data sources. Let's see if I can refresh this. Or maybe not. Let's see if I can create one remote. I'll quickly walk through this. And I selected my table, appropriate schema, and let's see if I can just go ahead and create this. Okay, so as I can see, I have an external table created. I can explore the tables, and as you can see on the SQL Server side, it's just another table with the same the schema information as you would see for any internal table as well. And if I just explore the data, I can simply query the data from Oracle Server directly. So as you can see, I'm querying Oracle data using very implicit and very T-SQL friendly syntax in this case. And it's it's not just Oracle data source. You can use many other data sources as well. For example, I can create a external table against SQL Server, MongoDB, or Cosmos DB, Teradata. And while you don't see it in the wizard, I can create external table against Hadoop data sources as well. And just to show something else, I can the wizard in this case, the wizard in Azure Data Studio gives you a user-friendly interface to create external table against multiple source tables as well. So let's see if this works. And as you can see, I'm already exploring the tables on the remote SQL Server. And for example, if I were an administrator and I was creating something, I can pick multiple tables and process them at the same time. For example, I'm picking all the tables in the sales schema, and I can create external table against all those tables in sales schema at the same time. And I can now start querying all the data for the remote sales schema, and I can even try to join the data with the local source schema. And and while I'm writing all the queries, the T-SQL users do not have to be aware of where the data resides. They can focus upon the logic of the replication or the analytics part of it without worrying about how they will access the data source. So this is a good example of the Polybase demo, and it shows you that you can access the local data, remote SQL Server data, remote Oracle data, or remote Cosmos DB or MongoDB data, and you can build an analytics on top of your entire data. The SQL Server is capable of storing large amounts of data as well as accessing a lot of heterogeneous data source. But fact of the matter is that the data is only useful when it is analyzed, processed, and made sense of. Now, if you want to define, if you want to build machine learning model or analytics model, sometimes the Transact SQL language is not necessarily enough, and R, Python are traditionally used languages to define to process the data sets and build artificial intelligence and machine learning models. SQL Server 2016 and 2017 added support for R and Python integration with SQL Server. SQL Server 2019 added support for Java as a language. Now, the reason why we added Java as a language is when we we listened to the feedback from our customers who were using R and Python integration. They also told us that R and Python are great languages, but what they also wanted was additional capability or flexibility to do more programmatic things, to extend the T-SQL language with more generic functionality, not necessarily related to machine learning or artificial intelligence. And SQL Server 2019 added support for Java as a language with an extensibility model. Now, the most critical part of this is that R and Python integration was available with SQL Server 2016 and 2017 on Windows platform only. Now, with SQL Server 2019, you get the same R, Python, and Java built-in integration on both Windows and Linux as a platform, which gives you great compatibility across the OS platform. And it gives you secure and isolated and governed mechanism to extend the T-SQL language whenever required and process the data with artificial intelligence or machine learning algorithms in a controlled manner. And the most important part of this is that now you can essentially back up a database once again from Windows, restore it on Linux, and still get the same machine learning, artificial intelligence capabilities across the platform. So let's just take a look at another demonstration of machine learning and Java language extension. And I have also pasted a link over here, which I used to configure the setup. Let's see the demonstration of R, Python, and Java language extensibility with SQL Server on Linux. At this point, I'm connected to a SQL Server, which is in SQL Server 2019 installation installed on Ubuntu Linux in Azure. And since R and Python integration have been available ever since SQL Server 2016 and 2017, you might have seen that before. So I'm going to quickly walk you through the same integration that you had available on SQL Server on Windows, now available on SQL Server on Linux. So let's just do some early setup. I'm connected to SQL Server 2019 Developer Edition on Ubuntu Linux. First, I'm going to clean up anything if I had any leftover setup, and then I'm creating a sample database to hold my data. Now, I'm going to create a couple of sample tables in that to hold my data and the model, the machine learning model. Next, I'm going to create a stir procedure, which is using SP execute external script. And in this particular example, it's using R language, and it's using built-in ReverseScale R library. And it's a well-known data set in the library. So I'm just creating a stir procedure first. And now I'm going to execute the stir procedure to insert the data into the table I just created. And as you can see, it has inserted about 150 rows. Let's just take a quick look at what that looks like. So as you can see, some data has already been imported. About 150 rows were imported into the table. Next, I'm creating a stir procedure to generate a machine learning model based on the existing data set. And as you can see, this time I'm executing SP execute external script, but this time I'm saying the language Python. And I'm suggesting it use the Gaussian naive Bayes algorithm, and it uses the basic tables that I already created. So let's just go ahead and execute the store procedure. It should create the machine learning model and insert it into the models table I just created. If we see the model, it's already inserted, and it's just a binary model. It's a binary representation of the machine learning model. Next, I'm creating a store procedure to actually use the model to do the prediction. And in this case, I'm just using the same data set that I already used earlier. And now once again, I'm using execute external script with Python, and I'm using the same model that I created and the same data set that I had preloaded earlier. And now, as I execute this store procedure, we can see the whole the prediction against the existing data set. And as you can see, it has processed the data set, and it has done the prediction appropriately using the Python algorithm. So in the single demo, I have shown how to use execute external script with R or Python against SQL Server installed on Ubuntu Linux, SQL Server 2019 on Ubuntu Linux. Now, let's take a look at another example. This time, I'm using Java language. I already created most of the setup to save some time. Basically, I created a database and inserted. I created another sample table, inserted some sample data in that. Then what I did is I actually created a Java language, and this is called language extensibility. The steps to include the language extensibility are very well documented. It's part of my PowerPoint deck as well, as seen earlier. Now, I'm creating supporting libraries using the Java language extension. This is built-in library, and then I'm using a regex code or regular expression code. Now let me show you the regular expression code. So as I might have mentioned, SQL Server has Transact SQL as its basic language, and it is extremely powerful language. But at the same time, there are certain things which are better done in a programming language versus the Transact SQL language. One of the prime example of that is regular expression. And regular expressions are better done in a programming language such as C# or Java. In this case, I have written some Java code which takes inputs in terms of the one input table and regular expression, and then it basically processes the input table versus regular expression and outputs a certain number of rows. And what I've done is I have already compiled this code and it created a library out of it. And then I have what I have done is I did execute external script, and I have specified that I want to create a function out of a regular expression sample code that I just showed in Java. Then, for the ease of use in the Transact SQL, what I have done is I have created a function, a wrapper function around this execute external script, so that it's easier to use in the regular Transact SQL language. After that, now what I can do is I can simply use this store procedure to execute my regular expression against any table, input table that I can represent. So in this case, for example, I had inserted certain rows, such as this sentence contains Java versus this sentence contains also Java, but the one contains all small letters, other contains one capital and rest of the then small letters. And there are some additional rows with slightly different patterns. And I want to try and pull these different patterns using this regular expression. So in this case, for a first example, what I'm saying is that I want to output all the rows which have word Java inside them. And in this case, I don't care about the casing for the word J. So now this is invoking Java code and then running against a table. And output the rows, even if they are, even if the word Java is spread or embedded in different places, and even if it has slightly different casing. Now, as you can imagine, this can be quite useful in many scenarios. For example, if you have some sort of a data set and you want to see how, which type of dates are included in part of your data set. So in this case, for example, I've given a regular expression which can output the date type of information. So in this case, for example, there is a date in one of the rows, and it can process that as well. And there are other expressions such as the rows with digits inside them, or there could be rows. So I can output also rows which have more phone number-like structures and varying different kind of phone number-like structures. So as you can see, in this case, I have got two different phone number-like architectures in different rows, one with dashes and one without dashes, and I can use regular expression. And I could do the same thing with transact SQL, but it's using regular expression in Java is far more efficient. And now with language extensibility with Java, you can achieve that. Now let's talk a little bit about SQL Server availability group support in Azure VM. Now this is actually not specific to SQL Server 2019. This is more about pacemaker clusters in Azure. So traditionally, Windows failover clusters have been used to provide high availability to SQL Server failover clusters or always-on availability group. Now, the equivalent of the Windows failover cluster in the Linux world is pacemaker clusters. The pacemaker clusters were not supported in Azure VM environments due to lack of Azure's fencing agent for pacemaker clusters, and we'll talk a little bit more about it. So Microsoft team worked with the Red Hat and SUSE team especially to build Azure fencing agent and provide support for pacemaker clusters in Azure VM environments. With this, now you can build SQL Server failover clusters or failover cluster instances or always-on availability group environment over Linux pacemaker clusters in Azure. So you get the same functionality that you had on premises on Azure as well. And let's talk a little bit more about that. So I'm not going to go into too much technical details about this diagram. This is a very simplified version of a diagram which defines the Linux pacemaker cluster implementation. Basically, what we have are 3-node Linux pacemaker cluster. The Coro Sync service in the Linux pacemaker cluster provides the quorum management on the OS side of things. In this case, we have installed SQL Server on each of these nodes to provide a replica environment. There is a pacemaker service which sits on top of this pacemaker cluster, which provides the resource management. Now, for example, for all of SQL Server AG resources or virtual IP resources, which are used to provide the AG endpoint functionality. The most critical part in this case, though, is the fencing agent. The pacemaker service or the pacemaker cluster uses the fencing agent to essentially reboot a node, a Linux node, if it identifies that node to be unclean in the state, or essentially if it identifies that a node is unresponsive, a Linux node is unresponsive, it uses the fencing agent to so-called fence the node, which basically reboots the node and gets it into a clean state. Now, this is the fencing agent requires more hardware-specific knowledge because it needs to know how to reboot a VM or a physical machine. Now, the challenge for Azure was that there was no fencing agent available which knew how to reboot the Azure VMs in a clean manner and a quick manner. So Microsoft worked with our Linux partners to build an Azure ARM fencing agent, so which now allows us to build the same kind of pacemaker cluster. The overall functionality is exactly the same. What we now have is a new kind of fencing agent called Azure ARM fencing agent. So that allows us to build a fully supported Linux pacemaker cluster in Azure, which provides the high availability, including the ability to reboot the node quickly if it finds the node to be unresponsive. And you can also have the AG cluster and the virtual IP resource, which provide the high availability to the AG availability group resource, as well as to availability group endpoint functionality as well. So let's just take a look at a demonstration of what a Linux pacemaker cluster looks like and how to manage it. And I have also pasted links over here on how to configure the AG cluster, or how to configure the pacemaker clusters with always-on availability group in Azure. These are very specific. These two tutorials are specific to Red Hat Enterprise Linux, and we have the tutorials for SUSE Enterprise Linux in process, which will be published in very near future. And we are also working with our Canonical partner to build Azure ARM fencing resource for Canonical as well. Now, let me show you an example of configuring high availability or availability group on Linux pacemaker clusters in Azure. In this case, walking through the entire configuration steps would be unwieldy because it takes a while. So I'm just going to show you a fully prepared cluster. I'm going to show you a RHEL 8 cluster. In this case, I got 3 nodes of RHEL 8 or Red Hat Enterprise Linux 8, node 1, node 2, and node 3 in a same VNet. I have also created an Azure Load Balancer resource that I will talk about in a minute. And I have installed Pacemaker cluster on top of it, enabled StoneIt agent, and also enabled or created an availability group on top of it. So let's just take a look at it as to what it looks like in SSMS or Management Studio. So for example, I'm connected to my node 1, and let's see what the node 1 looks like. I've got one database which is in availability group. Let's see what the availability group status looks like. So it has one availability group, AG1, and it is currently in the secondary. The node 1 is currently a secondary replica. So let's take a look at what a node 2 looks like. And in this case, my node 2 is my primary replica. And node 1 and node 3 are my secondary replicas. I also have one database inside that and AG listener on top of it. The AG listener resource or AG listener definition looks something like this. It's basically a virtual IP address and a port number information that I have bounded. So let's see what that looks like in terms of the pacemaker resources. So I'm connected to my node 1 in this case, and I'm trying to show this the resources on the node 1. So as we can see, my cluster name is AZ or Azure HA cluster. It has 3 nodes, node 1, node 2, and node 3. I have configured the StoneIt agent of type Azure ARM fencing, and this is what allows us to be able to support this pacemaker cluster, RHEL pacemaker clusters in Azure going forward. As you can see, I've also created an availability group resource, AG cluster, and it has one master replica, which is on node 2, and two secondary replicas on node 1 and node 3. I have also a virtual IP resource associated with it, which is the same as my AG endpoint resource. So let's see what my resource configuration looks like. As we can see, my virtual IP resource is the same as my availability group endpoint resource. I also took the liberty of defining an easy to remember AG endpoint or DNS entry and bound it to this AG endpoint IP address, and I've connected to that using the AG endpoint as well. As you can see, right now I'm already connected to my primary replica, which is on node 2. Now, just to see what the resource movement looks like, you might remember that when you are moving resources for SQL Server availability group on a Linux cluster, you do not move the resources using tsql. You must use resources using the pacemaker command line. So in this case, this is the command line that I'm going to use. It's PCS resource move, and I'm asking the master resource for AG to be moved to node 1, and then do appropriate cleanup on top of it. So let's see how that goes. So I'm asking the resource to move to node 1. So let's see if I can connect to node 1 and see if the resources are moving to this as. And as you can see, my node 1 has already become primary. So let's see if my AG endpoint functionality is also working fine. I'm connected to my AG endpoint, and let's see if I can refresh my availability group resource over here. Obviously, in the background, it has to reconnect. So it might take a few seconds for it to reconnect. On the Linux side, okay, and as you can see, it's already connected to my primary replica, where node 1 is my primary replica. Okay, so as you can see, we can easily move resources using PCS resource move command. Now let's try to see if we can test the fencing functionality. Now, fencing functionality is what's newly available. We worked with the Red Hat team to create Azure ARM-based fencing agent, and this is what gives the Stoneit agent or pacemaker cluster the information about what type of resources these nodes represent, the node 1, node 2, and node 3, that they are Azure VM, and how to reboot this VM so that they can be brought into clean status according to pacemaker cluster. That's how pacemaker cluster understands and manages the resources if it deems any of the resources to be dirty. So now we know that node 1 is my master rep, and node 2 and node 3 are my secondary replicas. Just to see test what it looks like, let me just fence my node 1. And essentially, when I'm saying I'm fencing my node 1, this is essentially a test command this is telling pacemaker cluster to assume that node 1 is not clean. Now, since I'm executing it from node 1, what pacemaker cluster will do is essentially it will reboot node 1. It will assume node 1 to be unhealthy, and it will essentially reboot node 1. So I'm moving to node 2 in this case and executing the status to see what the current status looks like. And as we can see, it's saying that it's promoting node 2 because it has already stopped node 1, and it is keeping node 3 as my secondary replica. So it takes a few seconds for it to promote the replica. And as you can see, it says it has already started the resources on node 2 as its primary replica. So now let's see if I'm connected to my AG endpoint, and let me see if I can refresh my resources and get the updated status. And in this case, once again, I can see that my node 1 is unclean and it is in rebooting state, so it shows as disconnected. Node 2 has already become my primary replica, while node 3 is my secondary replica. So now, with new pacemaker or Stony agent being available for pacemaker clusters for Linux VMs in Azure, you can create high availability based configuration, availability group environments for SQL Server high availability in Azure as well. And what I just showed you is a pacemaker cluster, a 3-node pacemaker cluster using Red Hat Enterprise Linux. But SUSE Enterprise Linux also supports pacemaker clusters with appropriate Stony sensing agent. For example, this is my second cluster that I have created. It is based on SUSE Enterprise Linux, and it's currently connected to my primary replica, which is on node 1. So if I go ahead and connect to this node and find the server name, it says my server name is sln1 or /node 1. And if I see my version name, it should give me SQL Server 2019 with on SUSE Enterprise Linux. So as you can see, it is saying that it is SQL Server 2019 on SUSE Enterprise Linux. So as you can see, you can create pacemaker clusters with full high availability and fencing functionality, and you can create SQL Server high availability configurations as in availability groups on top of this pacemaker clusters in Azure. Next up, I want to talk about SQL Server replication and CDC support on Linux. Now, replication and CDC are very well-known features. They have been in SQL Server for over 20 years, and they are very well used for data transfer or data movement mechanisms for many of the application scenarios, especially where moving or movement of the entire data set is not required and you need a partial data movement functionality. So this is very well defined and very well used feature. When we introduced SQL Server 2017 on Linux, replication and CDC were not supported. Starting with SQL Server 2019, the replication and CDC functionality is available on Linux platform as well. And because we understand how important replication and CDC are for our customers, we have also backported replication and CDC support to SQL Server 2017, starting with CU 18. So you can now create full transactional and snapshot replication environment, or use applications which use CDC for ETL kind of functionality, for example, on SQL Server on Linux environment. And the most important part is that these are fully contained in MS SQL Server, so you don't have to install or enable anything other than just the SQL Server agent, and you get the same functionality with on how to use it with SSMS. So you have the complete parity in terms of functionality with Windows as well. And by the way, you can create a replication environment across Windows and Linux environment as well. You just have to make sure that the shares used for a transfer of the snapshot, for example, are accessible to both environments. So now let's just take a look at a demonstration of the CDC functionality. Due to limited time available, I'm not going to show the demonstration of the replication functionality, but I have also pasted a link over here on how to configure and use the replication functionality on SQL Server on Linux. Now let me show you an example of the CDC or change data capture functionality. Now starting with SQL Server 2019 and SQL Server 2017 CU18 onwards, replication as a functionality has been supported on SQL Server on Linux environment. Now, replication has been a very popular data transfer or data movement technology for over 20 years. One of the additional piece of technology which is very popular and uses replication as a foundational block is CDC or change data capture. Many of the ETL tools use CDC functionality as its foundation as well. So let me just show you how you can use CDC with SQL Server on Linux environment. Once again, I'm connected to SQL Server 2019 on Ubuntu Linux, and I'm trying to create a sample database, and I'm enabling CDC on top of it. Now I'm creating a sample table inside this database. And I'm enabling CDC on top of the table infrastructure, and I'm essentially giving it a bunch of columns to monitor for change data. So let's see if that works. And as you can see, appropriate CDC infrastructure was created underneath. Now, let's just go ahead and verify the metadata of the CDC infrastructure that we just created. And as you can see, we are monitoring about 6 columns on a table. So now, let's try to insert and update some dummy data into the table. So I inserted about 17 rows and updated 5 rows just to see what kind of data set we can see in the CDC tables. And as we can see in the CDC table, we can clearly see the insert, update, and delete operations appropriately being captured. Next, I want to talk about one more feature, distributed transaction support for SQL Server on Linux. Now, distributed transactions have been available to SQL Server for over 20 plus years, and they were available on SQL Server on Windows with MSDTC support. When we initially introduced SQL Server on Linux, because we did not have MSDTC service on Linux platform, the distributed transactions were not supported. We got the feedback from customers that distributed transactions are quite a valuable feature, especially in linked server scenarios or with certain enterprise application development platforms such as JBoss or Java enterprise platforms, which use the distributed transactions quite extensively. And another feedback that we got was that on the Linux platform, the exit transactions were more de facto standard over OLEDB or OLE transactions, which are more native to Windows platform. So starting with SQL Server 2019, we have introduced support for MSDTC on Linux platform. And one of the additional things we did is we have added support for native exit transaction capability. So the drivers and SQL Server both have been modified so that they can support exit transaction coordinators natively. Now, another thing what's interesting is that MSDTC configurations are also supported on container runtimes as well. What that means is that you can have some very interesting configurations with containers in MSDTC. So for example, if you have multiple containers running within a same virtual network or across overlay kind of network, you can configure MSDTC to communicate directly from container to container. Or if you have applications or other servers which go across hosts and are not part of the virtual network, the container virtual network, in that case, you can configure the container to talk to the application server via the host network as well. So the MSDTC configurations being available in the container scenarios opens up quite a few interesting possibilities as well. I want to quickly talk about a few more improvements. One of the more important one is the support for persistent memory, especially in case of Linux environment. The persistent memory is supported in a couple of different frameworks, which is hybrid buffer pool scenario, or you can put your database files directly on the persistent memory and configure them for enlightened IO, which will allow SQL Server to bypass the IO stack and use persistent memory in almost memory-like configuration, which allows it to have quite a fast IO. Of course, since intelligent QP or accelerated database recovery and some of the additional features are built into SQL Server engine themselves, and since we are using the same Windows binary on SQL Server on Linux, all those features translate directly to SQL Server 2019 on Linux as well. I want to call out a few container-specific improvements. Namely, now you can acquire the SQL Server container images from MCR or Microsoft Container Registry, which is a secure infrastructure, and you can rely on Microsoft to provide you containers in a secure fashion. Starting with SQL Server 2019, the containers run as non-root containers by default, and because they are non-root containers, which is a more secure configuration, they are also supported in OpenShift configuration, OpenShift deployments as well. And of course, starting with SQL Server 2019, we also natively ship some of the Red Hat-based containers, such as SQL Server 2019 on RHEL 8 container images. Of course, you can build your own custom containers as well, and that's a whole different discussion by itself. So I just want to quickly talk about what we have learned from our customers who are using SQL Server on Linux. And one thing we can safely say is that SQL Server on Linux is quite popular. I mean, we have millions of container pools. We have got hundreds of thousands of instances and cores running SQL Server on Linux. We have got many customers running SQL Server on Linux in production environment. And while we have mentioned just few of the names over here, they are a minute subset of the true customer base that we have. And while we were talking to them, what we learned is that there are a couple of different types of customers who are attracted to SQL Server on Linux platform. The first set of customers that we have talked to are the they have their own entire application infrastructure and rest of the ecosystem, which is already built on Linux platform. And they wanted to standardize on Linux, SQL Server on Linux as more of a operational standardization, which allows them to save expenses on the operational, basically save operational expenses. The other set of customers that we talked with are the customers who have been using Linux platform and other database engines for their existing applications, or even they were evaluating a new application or new workload for with other database systems. And they now have a more cost-effective, at the same time, extremely scalable and highly functional database engine such as SQL Server available on Linux platform. And they are starting to consider SQL Server quite seriously for most of their new workload, as well as trying to migrate their existing workload as well. And there are a few other questions that we get asked all the time. So I just want to try to address them very briefly. Is it the same as Windows? And as I said before, With the SQL file, we are running the same binary on Windows and Linux for SQL Server. Is the performance same as on Windows? And the answer to that is yes. The performance is nearly identical on the Windows. In fact, it's slightly workload dependent, and for most of the workload, it never deviates more than a couple of percentage points. So basically, while it depends on your workload, you should never really see a difference of a high scale or high magnitude when you run your workload against SQL Server on Windows versus Linux. Is licensing the same as on Windows? And the answer is yes. Basically, you can use the same license that you have on for SQL Server on Windows against SQL Server on Linux deployment as well. Another question is, do I need to know about Linux? And the answer to that one is slightly, it depends. And the way you should think about it is that if you are a SQL Server DBA and if you have been working operationally on the SQL Server side alone, then you don't really need to understand about Linux. But at the same time, if you are a system administrator and if you have been working on the some of the OS administration as well, such as the disk management, then you obviously will need to understand the same functionality on the Linux side of things as you know on the Windows side of things. Another question is, is SQL Server different in container? And the answer is no. It's just a different deployment technology, but the engine running underneath is identical. It's basically the same binary. Another question is, we need multiple instances on the same machine, and that's not supported on SQL Server on Linux. And the answer to that is you can use containers to achieve nearly identical functionality. And the one more point I wanted to mention was that while SQL Server is benefiting from the Linux ecosystem maturity, SQL Server is also contributing back to the Linux ecosystem. And you can read about one of those contributions, and this is one of many. This is just one of many contributions into the Linux kernel with FUA support and XFS performance in Bob Ward and Bob Burr's blog. So, and just want to quickly mention over here, in recent times, we have focused a little bit more on SQL Server on Linux benchmark because we wanted to essentially compare the SQL Server on Windows and Linux benchmarks. And as you can see clearly over here, SQL Server on Windows and SQL Server on Linux benchmarks are nearly the same as SQL Server on Windows benchmarks. So basically, whether you are on SQL whether you are deploying SQL Server on Windows platform or SQL Server on Linux platform, you should get the highest quality and highest performance possible with the infrastructure that you have. So I just want to briefly recap with what we talked about, and this is basically I just want to highlight that essentially with SQL Server 2019 on Linux, you have basically the same functionality or near functional parity between Windows and Linux platform. In fact, it's quicker if I just mention things which are not identical, which are essentially some of the BI services which are not available on Linux platform, and a couple of niche features such as file stream and file tables, which are available for SQL Server on Windows but not available on SQL Server on Linux. Otherwise, you get the same basic OLTP, advanced OLTP, the high availability features. You get the same security features, and you get the same data warehousing features such as column stores and Polybase, and you get the same machine learning services and the T-SQL compatibility across SQL Server on Windows and Linux. And in fact, you also get the same kind of tools across systems as well. So, for example, SSMS works the same between against SQL Server on Windows and Linux, as well as you get the tools such as Azure Data Studio or SQL CMD, which are natively available on both Windows and Linux platform as well. With that in mind, I just want to briefly point out a few of the resources, and they are going to be part of the slide when you acquire that. And with that, I just want to say thank you very much for your time. I hope you enjoyed the session, and I hope to see you again at SQL Bits. Thank you.